from the last few lessons when we learn a different method for evaluating project alternatives, including net present value (NPV), internal rate of return (IRR), benefit costs analysis (B over C), and the payback period, or also known as break-even analysis. And for this lesson video, I want to give you a big picture of how to evaluating mutually exclusive alternatives using this method that we have learned. But before, let's go back to a local project that use this method so that we can see how they are using, and then we go back to a theory of how we can do that with the different equation, different analysis that we have presented in the last few lessons. And as you can see in the first video of today's lesson, I show you the example of Lee County Complete Street. What is that about? Go to the first videos. And for this, as you can see, they use different method. And what is the project about? That you go to, and that already available on Canvas, so you may take a look at that. So this project is spread throughout the Lee County, including our FGCU. Get benefit from this federal funded project for the Complete Street to improve the main access road to our FGCU. And as you can see, just go show you the map. You see from the bin map, and you see our main entrance for FGCU a few years ago. And as you can see, no landscape, the median, natural here, and simple sidewalk. So in this case, it's not considered a complete street. It have to be accommodate the bike lane, accommodate the walking street, and the landscape look better. So you see the main entrance a few years ago, and now with the money from FTCU and some money from the Lee County Complete Street, as you can see when they put in here, then a few years ago we improved the entrance, and now if you go to Google Map, so that is now improving compared to the previous one that you can see here. And this is the improvement. Now the sidewalk is bigger, the median, as you can see there, it have more palms, other tree compared to the old one. So, and then the landscape in the median and in the sidewalk, now you see that improving compared to the old. And that basically some portion of the money go from this tiger brand, and that bring the benefit, right? Make the landscape be better, so that the benefit that bring not only other part, but it also benefit directly to FGCU. And as a matter of fact, you can see on page 17, Project Party, it also have Florida Gulf Coast University get benefit from this project. And let's go back to the slide that I show you, the page that I show you in lesson 1 video. So to evaluate this project, whether it's available, we need to evaluate the cost and the benefit and the disbenefit, etc. And in this case, they use all the methods that we are talking so far. The net present value, and you can see there for this project, and then NPV $87 million. It's positive. It means the project is attractive with the NPV method. And that NPV, if people don't learn this class, they don't know what is net present value, what is 87 million about. Then another method that we also talk is the internal rate of return. And in this project, it's more than 20%, 20.27% per year. And that when you see that number, it look very big, and that makes sense. So people without studying the engineering economics doesn't know what is net present value. they can be able to say, okay, the net internal rate of return is 20% plus, then this project is attractive. And then with the public project, they also use the benefit cost analysis. We don't talk about the profit. We don't talk about the income for the public project. Normally, we discuss the benefit, the cost, this benefit, things like that. And that apply in this project here. So that you see the method that we're talking about, and they have a 20 years evaluation period from the completion 2015. Actually, they complete a little bit later to the 2035. So all the method that they use, that we are talking about, due in years. So now it turned, so you see that that's applicable even in our local project in Lee County. Use all the method we are talking about. So it's important for you to understand this method. And you're interested, please go ahead to read the report, one available on Canvas for this project, and to understand with how people determine the benefit, operation maintenance cost, initial cost, etc. So let me go to the last slide, and it's important so that give you a big picture that we cover all the method that we discussed in terms of financially evaluating project alternatives, and that is the last slide in here in today's class. So comparing mutually exclusive alternative, a big picture. So we have 4 methods we already discussed: NPV, net present value; IRR, internal rate of return analysis; BOC, benefit cost; and NP, payback period. And you go to the previous lessons and today's lesson to learn what is that about. But here, big picture, summarize what we learned. How to find net present value. First, how to find net present value. Simply put the I in that equation equal to minimum attractive rate of return. Find out the equivalent present value of all the costs and benefit at time 0. Then whatever the number you find out, that is NPV. And then for the internal rate of return analysis, instead of with the same equation in NPV, but instead of plug I equal to MAR, normally the problem give you consider I that an unknown, I star, and set that NPV equal to 0. And that an equation. Use your calculation, your calculator. And by now, you should be able to do that. Otherwise, please practice with calculator. How can I find out I star? I set up the equation correctly. It's extremely important. So practice that. Otherwise, you use trial and errors, and that a lengthy process. And I show you in one problem when we talk about the lesson IRR analysis. So set it equals 0, then you can find out I star. And that I star make this equation is mathematically correct. That actually the internal rate of return. Then they go to the benefit cost analysis. We separate the benefit, this benefit, and the cost. What are they? We already talked in the lesson. But we have to convert in the common unit. Can bring all the money, benefit, cost, operation maintenance cost, this benefit, back to time 0 and compare to the initial cost at time 0. So that is one way. In the problem 1 that we talked today, instead of print it time 0, I print the initial cost, equivalent amount annually, uniform amount. Then you can compare with the other uniform amount like benefit, annual cost, etc. And with all of that conversion, we talk about equivalent. We have I equal to MAR, so that is similar to the NPV. So B over C on the use the equivalent equation, the I equal to MAR. And then the payback period, similar to IRR, the NPV times 0, but the I star, in this case, I equal to MAR, but the N in that equation, because we need to have number of years, the N's equal to N star. And make it equal to 0. And when you have that equal to 0, the n star that make this equation NPV n star equals 0 correct mathematically, then that n star, we call it NP, payback period. So that is how to find with different methods. And when we evaluate one project, if we have one single project, like Lee County Complete Street Initiative project that I just showed you, then the NPV, if it non-negative, then it's viable, financially viable. For example, the Lee County Complete Street, the NPV, net present value, 87 million. So it's greater than 0, it's viable. IRR, internal rate of return, greater than MAR. The IRR, not greater than 0, not greater than 1, it's greater than MAR, minimum attractive rate of return. And for the Lee County Complete Street, if you recall, that is 20.27%, which is significant compared to the MAR typically for public maybe 5-6%, so that huge amount, so that is greater than MAR, you can see that. And then for the B over C, it compared with 1. If the ratio greater than 1 or equal 1, then it means that benefit exceed cost, then that project considered viable. And for the payback period NP, it's acceptable to the decision maker, so no threshold compared to the other 3 methods. And you can see there is threshold in here, greater than 0 for NPV, greater than 1 for IRR, greater than 1 for B over C. But this is acceptable to the decision maker, no threshold. For example, if you evaluate a project and you want that project have to break even, return on the money, initial cost, and stated return by 10 years, then the NP have to be less than 10 years or 10 years. It cannot be exceed 10 years. So that is based on the preference of decision maker. Some people may say 20 years. Then NP have to be less than or equal to 20 years. So that basically how that payback period depends on the how acceptable decision maker is with the different characteristic of the project, the context, etc. Now that is for one project. How to compare the alternatives? And when to compare alternatives, we need a few things that we need to consider. The first, should we use alternative have to be the same life? Whether the challenger and defender concept need to be used. And when you compare which an alternative is preferred. So those are the questions we need to ask and answer when you comparing mutually exclusive alternative. So let's talk about the same life, whether it should be a same life, LCM, least common multiple, or planning horizon. All the first method and first 3 methods, NPV, IRR, P over C, have to be the same life to compare apples and apples. And remember, we have 2 approaches. Approach number 1, least common multiple. 2 machine or 3 machine, 3 option, 4 option. The least common multiple of the useful life for each of the option, that will be the same life we are talking about for approach number 1. If the problem specifies the planning horizon or study period, let's see, we have to compare that over 20 years, just like the one that you see in this project. They over 20 years evaluation, then you can see that the planning horizon is 20 years. So that's specified. Keep that in mind. To either LCM if it's not stated, or the planning horizon if it's stated explicitly in the problem. And that applies for all the first 3 methods, NPV, IR, and B over C. For the payback period, it's not applicable because that we want to find out when the project is going to be return the initial costs and the return that we expected. So that not apply same life or not. And with the payback period, remember, we ignore the cash flow after the payback period, and that's one of the disadvantages of this method, and that also the reason why you don't compare alternative. Solely use the payback period. We have to use other three methods. And other three methods, if you get the answer for NPV, if you do correctly, the answer for IR for B over C should be the same answer for the first three methods. Which is, if you choose alternative one with the NPV method, if you apply RR, have to be, for sure it will be alternative one, and same for B over C, but not payback period, as you can see in problem 2 today. Keep that in mind. And then should I use the challenger and defender concept, the three step, rank in the order, find out the first defender, and then incrementally increase challenger defender. So that three method, I go back to the lesson internal rate of return analysis. Should we use that in NPV? Luckily, you don't have to. You just compare NP for PV, net present value, for each method. For IR, yes, you have to use that. Go back to that lesson. B over C, yes, but I don't show you a problem in today's lessons, but we have an additional practice problem with solution. Use B over C with the challenger defender. Go ahead to practice and see that solution. If you're not sure what is challenger defender, go to the IRR method, the previous lesson, to see how we process with that IRR analysis with challenger defender. And then the payback period, of course, are not applicable for challenger defender, because we treat each alternative separately, find out the payback period for each. And then which alternative you prefer for different method here. For NPV, the maximum NPV for all of the alternatives we are evaluated, then that is the best option. The best option is the option that has the maximum net present value. And of course, to be financially viable, have to be non-negative, and you can see that the maximum non-negative. And then the IR analysis, we need to note the IRR for each alternative. You see, incremental IRR, whether we justify to improve, to put more initial costs, to jump from the smaller initial investment alternative to a higher initial cost alternative. That we call talking about the opportunity cost, incremental IRR, not IRR for each method. And then that incremental IRR greater than mark, then we select the challenger. If it's less than mark, then you select the defender. Make sense? So go back to that lesson to think about it. And then similarly for benefit cost analysis, and practice that in the additional problem today. The delta B over delta C, that delta, why I don't call it B over C, but delta, that is incremental benefit. If I jump alternative with the lower costs, lower initial cost than a higher initial cost. Everyone want to put less initial cost, don't want to put a lot of money. But because you can use that money for somewhere else. But if you can put more costs in more investment in a new alternative, and it's justifiable in that what? We put more costs, so we increase the denominator, delta C, but the benefit, incremental benefit, is much higher, far beyond the additional cost that you put in. It means that that ratio greater than 1. Then challenger, you go with the project, the alternative which have higher initial investment, but it not justified, less than 1. It means the incremental benefit is not justifiable for the additional cost you put in when you jump from the lower cost alternative to higher cost alternative. Then you select the defender, select the one that less initial cost. That's common sense, right? So that is the B over C. So let's practice that in the additional today practice problem. And for NP, you have payback period for each alternative, as you see in today's problem, problem 2. And for yes, should we select with the minimum payback period? For example, problem 2 today, the machine number 1, that payback period is 5.8 years. Machine number 2, the payback period is 8.3 years. So 2.5 years different. If you select the minimum NP, then you select machine one, which is return your money after 5.8 years. It's shorter. But as you can see, this method should not be a sole measure of growth to evaluate alternatives. Why is that? As you see it in problem 2 today, because the the payback period ignore the cash flow after the payback period, and then we ignore the benefit after that. That may select the project based on the NP alone. It will not be comprehensive, and that's why they use with other method, NPV, IR, and or B over C. So with that, you see the big picture apply, and these methods are very important. Understand that, and of course, it will be beneficial not only for our daily life but for the project, for engineering or non-engineering project that you will see in real life.